Hello everyone, good afternoon. My name is Praheksa, a heating, ventilation, and air conditioning operator at Pambudi, Karawang. I am here to present my project called Modernization AHU or Air Handling Unit, Temperature and Humidity Control for Kasanah Cetak B Line B, Internet of Things space. By modifying the Kasanah Cetak AHU and adding a split duct air conditioning component that functions as a dehumidifier. These innovations aim to control the relative humidity level of the room, particularly the Kasanah Cetak production room, which needs to be paid attention to the air conditioning operation and maintenance unit. The proposed invention will address the requirement for air conditioning in the Kasanah Cetak room line B. The banknote production process is quite complex. In terms of meeting quality process is quite complex. Meeting quality standards, one of which is connected to the air conditioning of the banknote sheets, which must be considered. The Suri standard is temperature and production values for the banknote production room are 23 degrees Celsius plus minus 2, and the humidity range is 60% plus minus 5%. This control and monitoring system has been integrated with the current HVAC facility control. The goals of AHU modernization is to help increase efficiency by controlling humidity and temperature to the standard levels. The next step is modify the AHU, which will allow the operator to change the humidity. First topic that we have here is background, the factor that help drive innovation. At this time, the main concern is the Kasanah Cetak room, because the length of time for conditioning the banknote is highly depend on the air humidity conditions in the room where the banknote are stored, which have gone through offset, intaglio, and notch screen printing processes. They are still experiencing humidity fluctuation. If the humidity levels are too high or too low, it will be the print will take longer to dry, will be uneven, and will be wavy. Of course, this will be a challenge because conditioning banknotes takes longer and is less efficient. One of the causes of this scenario is that the installed AHU machine still employs a traditional form of AHU that cannot automatically adjust temperature and humidity. Operators still have to manually operate fresh air damper opening and closing system to manage temperature and humidity. The next one is objective. What we want to achieve or we want to solve here is, first, we want to maintain stability and quality of the banknotes, and then second, to ensure stability and optimize conditions during the production process, and the third one, reduce losses due to change, damage prints result, and increase efficiency. The next one is increase work productivity, and the last but not least, maximize operational performance and air conditioning maintenance by reducing physical fatigue and time in air conditioning, which formerly needed manually operated in the AHU room. And here's the AHU design. On the left side is existing AHU design, and the next one and the right side is extension AHU design. A humidifier system and a dehumidifier system comprise the air humidity control system. The humidifier system consists of a fresh damper that is open to allow return air and to mingle with outside air, increasing the relative humidity level. The humidification system comprises of a condenser coil and a 70,000 BTU per hour. As you can see on the extension AHU design, there is adding of unit AC split duct. Both are controlled by a multi-channel input and output PLC. As a result, the AHU return air mixes with outside air, increasing the relative humidity measurement. And the next one is KPI, or key performance indicator, or measurable value that tracks how effectively achieving a goal. Key performance indicator is a decision-making tool or metrics that is useful for making an easier measure and help evaluate the performance of the organization itself to achieve its strategic vision goals. A key performance indicators has several indicators, namely SMART, or we can say specific, measurable, achievable, relevant, and time-bound. The first indicator is specific. It is to maintain standard temperature and humidity levels. The most significant factor to consider and measure when adopting this innovation is air humidity, because the goal of this innovation is to keep relative humidity levels within a particular range according to the standards. And then measurable. By monitoring the temperature and humidity of the air installed in the production room, the condition air relative humidity parameters can be read or monitored. And the next one is achievable. Achievable is a quality review. This project has been budgeted and is now being implemented, with operations set to begin in January 2024. Following the completion of the AHU modernization project, quality reviews of temperature and humidity will be conducted. The next aspect is relevant to increase effectiveness and efficiency. And the next one is time-bound. After observing about 30 days, the conditioning of the banknotes before the implementation took 5 days, whereas after the modification only took 1 day. Therefore, the AHU modification process has an efficiency level up to 20%. The conclusion is the Internet of Things-based temperature and humidity control system employed has undergone feasibility tests on macro, market, industrial, as well as technical factors to ensure that it can be built. This AHU modernization innovation has been validated by customers and management through interaction with connected stakeholders. Based on the result of customer validation, it was discovered that the requirement for AHU modernization was in accordance with advance in the industrial era 4.0. And that is my presentation. Thank you for your attention, and I'm sorry for my misspoke or mispronunciation. And see you.